Hello ladies, so we're going to take a look at concavity, and in order to determine concavity we are going to use a second derivative test. So second derivative test is very similar to the first derivative test except it's testing a different portion of the graph. So let's go ahead and take a look at this, and what you see is two different phrases. One is concave up and one is concave down, and as you can see the phrase for concave up is shaped like a cup. So just like the saying, concave up is shaped like a cup. So anytime you have a cup, it has a U shape to it, right? Concave down is shaped like a frown. So on here, concave down, I'm shaped like a frown. So by definition, instead of just using the phrases, concave up is when your first derivative is increasing. Well, if your first derivative is increasing, what does that mean about its derivative? It means it has to be positive, just like our last test. So anytime your second derivative is positive, you're going to see that you have something that is concave up. It has positive values. So this looks like a smiley face, right? Well, anytime you have something concave down, that means the first derivative is decreasing, which then means our second derivative is negative. So if I move this down appropriately, I will then have a frown. The negatives will remind you that it has to be a frown. Okay, so enough of that. Let's actually go take a look and see what this means. So first, let me actually make this picture slightly smaller. You have a copy of this in your notes, so what we will be doing is we are going to take a look at how looking at these graphs can actually help you determine whether or not I'm concave up and concave down, and what that actually means. So what we're going to do is we're going to prove and name the intervals in our f of x function. So what we've done is we've written the equation f of x, and we've drawn its graph right here. Then we've also taken the derivative of f of x. So the derivative of sine of x is cosine of x, which I have right here. Right? So here's my f of x. Oops. Here is my f of x, here is my f prime of x, and I also drew the graph in this section right here. And then we also have our second derivative, so the derivative of cosine of x is negative sine of x, which is right here. Please ignore that right there. That's nothing. That's an accident. So anyways, what we're going to do is first let's take a look at our first derivative and find our critical points. By definition, our first derivative has our critical points are when the first derivative is equal to 0. So CP is when f prime of x is equal to 0. So if you take a look, I have a 0 value here, a 0 value here, a 0 value here, and a 0 value here. Now we're going to do the same exact thing and look at our test values and see whether or not my derivative is positive or negative. Well, this is kind of nice with a graph because you know something is positive when it's above the x-axis. You know something is negative. I'm sorry, you know something is negative when it's below the x-axis. So all I'm going to do is actually label our sections. So if you notice, this is above the x-axis. So this section right here is positive. This entire section right here is below the x-axis, which means this is all negative. This up here is above the x-axis, so I'm positive. And this down here is below the x-axis, which means I'm negative. So let's interpret this the same way we've done our previous problems. Anytime I'm positive, I'm increasing, decreasing, increasing, and decreasing. So let's go ahead and take a look at our function and see if this is true. So as of right now, if I am increasing to decreasing, this is the maximum and this is the maximum. And if I am decreasing to increasing, this is a minimum, and this is a minimum. So let's see if this is true for our actual graph. Right about here, and this is an estimation, is where my critical point was. Do I have a maximum on my graph? Yes, I have a maximum exactly at that point. So we do have a maximum value up here. All right, let's take another line. And it says I have a minimum at this point right here. So if I'm trying to do this as close as possible, do I have a minimum right there? And yes, I do. I have a minimum right there. And finally, if I do this side right here, well, sorry, not finally, I have two more. Here's one, and here is another. So if I take a look, do I have a maximum up here and a minimum down here? Yes, and so this is proof that the first derivative test right here works. Well, the second derivative test is what we use to determine concavity. So let's actually do the same exact thing and see what happens. And as of right now, I'm not going to give you the name of the points, but I will tell you that anytime my second derivative is equal to 0, that is an important point. So if we look at our second derivative, I have 3 places where it equals 0. There's one right here, one right here, and one right here. And let's label this the same exact way we labeled the first derivative. So everything in this section is below the x-axis, so this is negative. Everything above in this section is above the x-axis, so this is positive. This is negative, and this is positive. Well, I can't use the terms increasing and decreasing anymore because I've done that for the first derivative. The second derivative, on the other hand, deals with concavity. So anytime it's negative, I'm concave up in this section. So concave down in that section. Anytime it's positive, I'm concave up in this section. So let's take a look and see if that is true in this section. So what I'm going to do is I'm going to trace from here to here and see if I'm really concave down in our original function. So let's see. This is right here. Oh no, let's use a different pen. Let's see. Let's use this right here. So when I am at this point, I'm going to go from here all the way up to here. And according to this section should be concave down. So if I take a look at this area over here, we see that I am concave down. I am in the shape of a frown, right? Our next section is where our other 0 is, which is right over here. And if I go up, and let's use this color to mark it. So from here to here, am I concave up or concave down? Good, it's shaped like a cup. And if you see, that section tells me I'm concave up. And the last 0 I have is right, oh, that's the wrong color pen. The last 0 I have is right over here. Let me make sure I shift that just a little bit. Okay, and so I'm going to use green to look at this section. So from here to here, am I shaped like a cup or shaped like a frown? Shaped like a frown, which according to our second derivative tells me I'm concave down. And finally, in blue is this section right here. I know it's not a full cup, but doesn't this look like half of a cup? And as you can see, this is concave up. So our first derivative and our second derivative actually holds true points when we're running these different tests. And what we're going to end up doing is we are going to find these concavities, these increase decreasing, so that later on we can actually draw the actual function. All right. So I'd like you to take a look at these pictures, kind of let it settle in, and then the next section I will give you a practice problem or to show you how to do these mathematically. Thank you.